We see the sunrise in front of us as our life unfolds and stories told. We stand alone. Shadows awake the innocent, counting downward, counting down to the end. We see the sunrise in front of us as our life unfolds and stories told. We stand alone. Shadows awake the innocent, counting downward, counting down to the end. We see the sunrise in front of us as our life unfolds. We see the sunrise in front of us as our life unfolds and stories told. We stand alone. Shadows awake the innocent, counting downward, counting down to the end.
Okay, hello. Can you hear me? Hi, Vijaya.
Yeah, I can. I'm just on screen. One moment. Yep.
Yeah, no problem. Cool. Yeah, I
So
think.
you can hear me, right?
Yeah, I think it sounds a bit quiet. Maybe it's just my end. Let me see.
If you can just give me one moment, I'll just swap out the headset then.
Cool, cool.
Sure, thanks.
So everyone, hey. So today's Inspire session will be taken by Vijaya, and she's going to be doing it on, convolutional neural networks using Azure notebooks and Python. So a lot of you actually gave us feedback to tell us that you wanted to see more Python stuff, to see like machine learning, things like that, along those lines. So today we got Vijaya in to do a talk on that. She's done many talks for us, or at least one I think, during the Inspire virtual call we had, which was on machine learning as well. So yeah, this is similar to that, so hopefully all of you enjoy that. Thank you all for sharing. I see you're mentioning you're sharing the stream in the chat. Thank you very much for that. I think Vijaya is just going to swap out her headset.
Oh, can you guys hear me now?
Awesome. That sounds good.
Oh, thank goodness. This is my conferencing headset, that's why.
No
Okay, cool.
way.
So that's cool. Okay, so I'll just start. I'll just share my screen one moment. Let's go ahead and open up the presentation.
Awesome. Oh,
PowerPoint.
Dawood's joined. Hello, Dawood.
Yeah. Awesome. I'm so
Yeah.
glad that we
Oh,
started
sorry, this is
today's
not the
session,
one.
and I know she's gonna do a great job. I don't know, am I the only one who personally like Vijaya's presentations? Like she does so
I think
well.
we all
I
do.
mean,
We all do.
it's so
Oh, I have
clear.
a fan club now. That's nice.
Oh yeah,
So,
yeah, sure. Yeah, over to you, Vijaya. Just handle your session. Thank you. I'll be on.
Thank
I'll
you
be
so
Oh
much,
wait,
on
wait,
YouTube.
Dawood, do you
Sure.
wanna talk
Yeah.
about quickly about next week or?
Oh yeah. That's so sweet. Yes. So next week we are actually doing something else. Thank you so much, Salman, for reminding me. We are actually doing something else, and that is the first episode of that. It's actually a podcast. All right, and we are just
Sweet.
going to have someone you've all been looking up to share a lot of inspirational stuff with you. And guess who it is? Salman, should I disclose it?
Wait, should we? I think we should. I mean, it's up to you.
Uh,
It's up to you.
oh
You
yeah.
can do the
Yeah,
honors.
so we're actually going to get Pablo Veramendi, I mean our program manager,
Nice.
to come on MSP Inspire and then inspire all of you with our podcast show, episode 1. All right. So we would plead everyone to join us in making the promotion. All right. So it's actually for the love of the community, for the love of the world. And as of now, we need to share positivity because we found ourselves in a situation where it's all about inspiring. So MSP Inspire, just inspire people. Okay, so Salman, I think I'll exit here and then join them on YouTube.
Okay, I would also like to add one more thing. Is if
Sure.
you want, what I was mentioning before is the whole, we're basically trying to get talks which all of you want. So if you have any ideas for talks and any requests, we're basically trying to find speakers for that from Microsoft, from MVPs, and and we'll be able to provide that hopefully for you, and we'll be doing that on the same schedule
Yeah.
as we normally do. So every week we'll have a talk, and then we'll alternate between, say, someone from the industry and someone from the MSP community.
Yeah, and just to complete that, gone were the days when searching for materials to learn was actually a trouble. Today, MSP Inspire is running after everyone across the globe, asking what talk do you want us to do. We can get the right person to do it for you. So just tell us. We will drop the link in the YouTube chat so that you will be able to fill it out. All right. Thank you so much, Salman. Thank you for mentioning that.
No problem. And here's Vijaya's Twitter handle as well. Those are our Twitter handles. If you want to reach out to us, give us something that you want to hear about. I think I've just got the alignment slightly off for that. But yeah,
Yeah.
I hope you all.
I think Sabia is missing here, right?
Yeah, Sabi has got an exam tomorrow, so
Okay.
so she can't be
Cool.
here.
Yeah, but big thanks to our designers. Well, I mean, what's his name?
Sundareshwar.
Sundareshwar. Yeah, for putting together. Yeah, for putting together amazing stuff. I mean, so patient. Thanks so much for all. I mean, thanks to all of you for joining us
Just
on
look
this
at the
call. Let's have
chat.
fun.
Yeah, I look at the chat. How long is the session? So I believe Vijay is going to be about an hour, right?
Yeah, around that much.
Yeah, and
Won't be that long.
cool. And the podcast again, Anish, it will be here at the same place as usual. And we're probably going to put it on other platforms as well so that you don't have to use YouTube or something like that to listen to it. Mixed reality, yes. I could do a talk on the VR or AR project I did as well. So potentially that's something.
Yeah. You have to do it. You have to do it.
That's something Dawood's been asking me to do since I joined. I think. But I think without
I know.
Since like 8 months now.
sorry, Vijay, I think
Okay,
you cut out there.
No, I have never done a AR project before, so it'll actually be nice to look at how you should actually do it.
Oh, I could definitely show that. If everyone wants to, I'll be open to that.
Oh, definitely.
And cool. Without further ado, no problem, Tedros, and hi Ganesh in chat. Without further ado, we are now going to move on to Vijaya's talk. So I'm gonna now switch over to a screen and enjoy the session and put questions in the chat, and we will collate those for Vijaya for the end, and we will have a Kahoot. Okay, that will be at the end. So share the stream. Okay, this is
Sure.
gonna be really good.
So you all can watch
Yeah,
my screen
yeah.
right now, right?
Yeah.
Oh, sure. Then cool. So hi guys, I'm Vijaya Gajanan Budwarpu, just call me Vijaya. So I actually research mostly deep learning and stuff like that. So today's session will be about convolutional neural networks on Azure notebooks. So in my previous sessions on MSP Inspire, I talked about what deep learning was and how it differed from regular machine learning and etc. So I actually helped you guys build an actual handwritten digit recognizer. I think around 3 months ago when we had the session online. So today we will actually looking at a specific deep learning network that will be focused specifically on images. So let's go ahead, guys. One moment. So in the previous session, we learned about what's the difference between AI, machine learning, and deep learning, and so we also learned about what's the difference between deep learning and machine learning, why deep learning being popular nowadays, and why it's actually quite it's needed nowadays among. So if you want to become a machine learning engineer, you should also learn what deep learning is, and so in my previous session, like I gave an introduction to deep learning. The main difference between regular machine learning and deep learning is that deep learning has some most structures in deep learning have inbuilt feature extraction methods. So you don't have to spend time on feature extraction compared to actually doing the learning. Davudu, is your mic?
Yeah, is that? I was gonna ask. I think that's Dawi.
Sorry.
Sorry, I just muted you.
Oh, no
I'm
problem. Thank
sorry.
you so much. No big deal.
I thought
So
that
yeah.
was your mic. I was just about to say.
Oh no. I'm in my room.
Yeah, because you also
So,
said
yeah.
you had a conference mic. I thought, oh, did I mess this up?
Yeah. So basically, I gave an introduction to what deep learning is and what applications. For example, most autonomous cars like Tesla and all do have some kind of object detection method inbuilt, etc. I also talked about Microsoft's contribution to deep learning, specifically their ResNet architecture, which actually won like back in 2012, I think so, in the ImageNet challenge. And I also gave a practical on how to create a simple deep neural network for recognition of handwritten digits or the MNIST dataset. It's a very popular dataset. And in this session, we'll be working with a similar but a bit different domain dataset as well. So now here's the catch. What's a convolutional neural network compared to the regular DNN I taught you guys back in like the previous session? So it's specifically a type of network that is used to analyze imagery. In particular, what sets this apart from regular deep learning networks is that this network will learn spatial information. So when we talk about an image, it has many pixels here and there. It'll learn those specific features within that image. So as the name suggests, compared to regular matrix multiplication that you would see in a regular dense layer network, as I showed you last time, this network will use a particular mathematical operation called convolution. If you've taken calculus 3 or calculus 2, right, you might have seen this actually. I'm not sure about other colleges, but if you've taken high level mathematics in mechanical engineering or computer science, you definitely have seen how to do convolution in calculus. So a CNN network usually consists of more than one block. So each block is called a convolutional block, and within that block you will have several layers. So the first layer is usually the convolutional layer with the filters. Then you'll have the activation like ReLU or sigmoid, and then you'll have the pooling layer, and then you'll have normalization layers, like just to make sure that the data is going properly, and you'll have a fully connected layer for the classification output. So this is how a traditional CNN will look like. As you can see, you'll have this image input. So this is from the MNIST dataset. Okay, so you're the digit number 2. So the convolutional layer will go through these filters. So these filters will represent different kinds of features. So the convolutional operation is learning spatial features and spatial information. It's passing through, and then we pass it through a pooling layer, which will actually help us condense that information, and we'll only extract the most important features. So this is like this. So this is actually one block. So in this case, we have 2 blocks, so 2 convolutional blocks. So it's convolution pooling. At the end, we have a fully connected layer, which is connected to a classifier over here. So usually in the end, if you're doing classification, so you'll have 2 or 3 continuous blocks of convolution, and at the end you will have a fully connected layer, which will help you classify the output. So in this case, we'll have 10 layers over here because it's so for CNN networks, we have 2 important layers that we have to learn about. One is the convolution layer. It's the core building block of your network. So it consists of a set of learnable filters. So when you declare it, you'll give like 16 or 32 or 8 filters. So each of these filters will learn some spatial information from the image, and on subsequent testing, whenever it sees that feature, it activates basically. So during the forward pass, each filter will convolve around the width and height. I'll show you an image which will actually help you imagine this, and it produces a two-dimensional filter map. If you're working with two-dimensional images, of course, there's even a convolution 3D, by the way. So in our case, we are working with 2D images, and this map through the it maps to the dot product. So that's the operation. So when you stack these filter maps, so if you have 8 filters in the network, in the layer, you will have eight filter maps. So this produces the output for that layer. So therefore, the network will learn filters that would activate when certain features are detected in the output. So for example, in the second or third convolutional block, so if you train it on cats versus dogs, only when it sees that particular nose or particular whiskers, it will activate. So this is an image that will help you understand what the convolution operation is doing. So I have this image with certain width and height, and this is my filter map of 3x3. So it is going through each, so it's going 3 by 3 through the entire image, and it's performing a dot multiplication over here, and this is the convol feature map. So the next most important layer is the pooling layer. So why would we need pooling layers in convolutional networks? So it's a form of nonlinear downsampling. It helps us extract the most dominant features by reducing the spatial size. So in particular, pooling, there are multiple pooling layers. There's region of interest pooling, there's max pooling, there's average pooling, there's global average pooling. There are multiple types of pooling, but each type of pooling layer will have a certain characteristic that will make it useful in a certain situation. So the most common one that we use is max pooling. So if you can see this image on the right hand side, we have this this filter. Okay, so the filter has gotten 12, 28, and for 12. So when you apply max pooling, it will only take the maximum feature. So in this case, it will be 20. So 20 will come out. Similar thing, 30, 0, 2, 0, 30 will come out. So exactly like that. Now if we consider average pooling, on the other hand, it will take the average of all 4 these numbers, which is 13. And in the case of this, it will be 8. So max pooling is kind of very common because you want the most important feature all of them. But if you have several important features, it could miss out on some information. So just to recap, so you will have a convolution layer with the activation function. You will have the pooling layer. And if you want to perform batch domination, you will have it in between those layers. So these are the two main important layers that make a CNN unique in a sense. So I've given you a general introduction about CNN, but we'll only get to know how it works by actually coding it out. So now we shall actually do a practical on the convolutional neural network. So if you want to follow along, you can go to Azure notebooks.azure.com, which I'll be doing soon. One moment.
I'll leave the link for this in the chat as well.
So here I am on Azure Notebooks. So when you see the screen, you'll actually be on this page actually. So you can log in, and then you can go to My Projects. And over here, you can create a project. So I already created the code for this, and I'll be posting it on the MSP Inspire handle. So you can take a look at it. If you can't catch up with me, not a big deal. So let's create a project. So we'll just name it MSP Inspire, and then I'll make it public. Create. Okay. So now if you're on this page, make sure to press Run on Free Compute, because you need some kind of back VM to run it. So you have free compute so that you can use it. If you have a subscription to Azure like us MSPs, you can create a virtual machine and then use that as your backend. So let's create a new project, new notebook. Let's name it cnn.ipnb, which is the Python notebook, and I'm choosing Python 3.6. So new, and I'll press Run on Free Compute. And here we go. We'll be clicking on this. This is trust. And now it's connected. Cool. Let's start coding. So the first thing we need to import is TensorFlow. TensorFlow is the main backend that we'll be using, and for our API, we'll be using Keras. So let's import some important layers. So we'll just do from TensorFlow .keras.layers import dense input con2D, which is called convolution 2D. There's even 1D as well as 3D depending on your data set. And then you have max pooling 2D. We'll be choosing max pooling today, not average pooling. We're using batch normalization after our convolutional layers to help balance the data set again, normalize the data set again. We'll put a dropout layer before our final classification layer. So dropout basically does is that if you give it a number, let's say 0.5, 0.5 of the input will not activate. This actually reduces overfitting. If you know a bit of machine learning, you have to use reshape to change our input to something else, and we'll need flatten for converting our convolutional layer to a dense layer. So here we go. All right, let's see if it works. Coolio. One moment, F4 to import. So if you want to run these blocks, you have to press Shift Enter. That's like the shortcut. And I made a typo over here. Sorry. Cool. So this is there. So if you want to create a model, we need to import TensorFlow .keras.models. And I have to use from here. Sorry. There are multiple ways of creating a model. One is a sequential API and one is the model API. I'll be using the model API this time because it's more easy to understand. And I'll also be importing my importing the important optimizers. And from TensorFlow.keras.losses import sparse categorical. So we're using sparse categorical cross entropy because we have 10 particular classes in this data set. But if you only had like two classes like dogs and cats, then you'd use binary cross entropy. Cross entropy. Oh, this should work. Oh no. Oh, I'm so sorry about this. Oh, why is this happening? Cool. So we have our dataset right now, and we'll also import the dataset right now. So let's import the dataset. We'll be using something called fashion MNIST. It's like the MNIST dataset because it is like many samples, but it's little fashion. So you'll have you'll have skirts, you'll have jackets, you'll have pants and stuff like that. It's kind of a cool dataset. Fashion MNIST. One moment. Sorry about that. And we also need to import an important package called matplotlib. This will help us visualize our dataset. And we'll also need to import NumPy to help us with our tensor values. Okay, so these are all the libraries that we've imported. Now it's time to actually get the dataset. So X train, Y train, and X test, and Y test is equal to fashion MNIST dot load data. Okay, so it's going to download our dataset right now. So cool. Let's check the size of our dataset right now. So let's just take x.train. So our training set has 60,000 training images. Each image is of width and height 28 pixels. Let's check our testing set as well. X test. It's now 10,000. So you have 60,000 to 10,000 images. Cool. And if we check out our labels, oh no, So these are the categorical labels. So we have 60,000 same samples like this. So it's
Wait, is that Dawood again?
I think it's Dawood again.
Dawood, hello.
It's okay.
Dawood. Okay, I'm just gonna
I
mute
think
him.
okay, sure.
But
So
yeah, no, that's
as we can see, this dataset has 10 classes, but they aren't labeled properly. So I'm just going to label it for myself to understand. So we have t-shirt, we have trouser, we have pullover, sweaters, and we also have dress, coat. We have sandal, shirt, sneaker. What else do we have? Once again, we have bag and ankle
you
boot.
got like socks, right?
There's no socks in this, sadly.
Ah, what?
I mean, they're so arbitrary. Like the classes is like t-shirt and this shirt. I think
But
one's like the
it's the
formal wear.
Minist data set.
No, this is it's there are two types of MNIST data sets. One is for handwritten digits, and the other is actually fashion.
Yeah, but
I'll
like
show
they
you
should
guys.
have socks.
There's no socks. What can I do about it? If you want, you can make a new destiny. You can add your socks. That's so fun.
Make a pull request and add socks.
Since
please.
the pixel, just for information, photos are actually made up of pixels, right? So they're of 0 to 255 in like magnitude with like 3 different channels. Like for example, if you take just grayscale images, you'll only have one channel and 0 to 255. So 0 is black, 255 is white. And in the case of RGB images, you will have 3 channels, each for one for red, green, and blue. And the 0 to 255 will represent the maximum of redness or greenness or blueness. So with RGB, you can make any sort of color imaginable. But in this dataset, it's specifically grayscale. But nonetheless, whatever dataset you have, you need to normalize the dataset, because our values are now between 0 and 255. So if you try passing these values to the network, it'll take forever to train. So you normalize it between 0 and 1, and you do that by dividing it by 255. So I'm doing it right now like that. So cool. So it'll take some time for it to divide all the values. So give it some time. In the meantime, I shall help you visualize the dataset. So let's make a nice figure with size equal to 20, 20. Now we'll be running a loop which will help us plot all the images that we want. So I want 100 images, and so we need to have subplots as well. Subplots of 10 cost 10, and we'll just increase it by +1, I +1. So plt dot xticks. These are just like regular settings that you have to redo just to like remove those grid and all. Yticks is equal to nothing, and plt grid is false because we don't want any sort of grid in our image right now. And now we'll be showing the image. So IAmShow is the function for that. Xtrain I, and our CMap will be gray. Gray.
Does it have a lot of overlaps with like, because IAmShow is also used in MATLAB?
Some of them are actually quite like, some functions have same names usually, and in the case of Python, in the case of matplotlib, it shares a lot with R, which shares a lot with MATLAB. So it's like a standard. I think so. It's like a standard.
Okay. Thank you.
You can't. Some standards are like you can't change. So that's the. Oh wait, X label is wrong. Sorry. So since we have a clothing, we'll name it after our clothing. So train, instead of having numbers like 0, 1, 2, 3, 4, we want to see what type of clothing it is. So let's do that. So plt.show. What's wrong? Let's check our code one more time. Subplots. Sorry, my mistake. It's a subplot, not subplots. It's going to take some time because it's going through all the images and plotting it. Won't take long. So we can see our nice. So we have ankle boot, which which are actually just a Nike Jordans, technically ankle boot, t-shirt, dress, t-shirt, pullover. So I think sweaters. I think so. Sandals, lots of sandals, bags, pullovers, coats. So you can see like there's like a variety, and the good thing about fashionableness is that it gives you a variety of like different kinds of clothes. For example, t-shirt doesn't have to be specifically a t-shirt. It can also be a vest like this. So there's quite a variety. So it's like a good it's a good diverse data set. The one thing you should know in deep learning is that you need to have a good diverse data set. So if you were to take all t-shirts, this should be like red t-shirts, blue t-shirts, black t-shirts, small t-shirts, medium t-shirts, large t-shirts. So that way your model can learn to generalize better. So that's the important thing that you should keep in mind. So for our network, it needs a channel layer as an input. So I'm going to introduce a channel layer. So the channel layer will be, so you have the first argument as the number of inputs. We all know the image is going to be like 2028, and we're going to introduce 1 because it's a grayscale image. Same thing for testing also. So we'll do this as well. X test.
Do all the
28,
fashion minists come as grayscale?
Grayscale. Yeah, they do. But the thing is that if you go up over here, right, you can see that there's no extra channel layer.
Mm-hmm.
So you don't have to do this. You can also use np.expand dimensions as well, but I'm just using it like this so that you guys can understand what I'm doing. So over here, we have number of samples, height and width over here. So the same thing, so the reshape function helps you reshape the entire thing. So I'm going to add same thing, number of samples, 28, with an additional dimension for the color output. So in this case, it's 1.
Yeah.
Or else our model will throw an error. There are other ways to solve it, but I'm just going to do the lazy way, basically.
Mm.
So here's the fun part, guys, making our network. So let's create our input layer, which is our input of shape equal to 28, 1. Oh no, I made some mess of it. There we go. So now we're going to create our convolutional layer block. So let's name this as block 1. This is just a comment, guys. So convolution 1 is equal to convolutional 2D. And since it's a small data set, I'll start off with eight filters. Kernel size 3. So the kernel is that square that you see in that image. So I'll take a kernel size of, let's just say 3. I'll just give it activation ReLU. Usually all the activations are ReLU, leaky ReLU, or some format of ReLU. But at the last layer, you will need to decide between sigmoid and softmax. Sigmoid is for binary classification. Softmax is for multiple classification, like 3, 4, 5, up to 10, whatever it is. Don't make the mistake of putting only 1. I'll just remove, but not a big deal. So I'll just so our convolution layer has these parameters, and the input to this convolution layer is defined in the last in brackets. So in this case, it's like passing a function basically. So this is our case. So just to make sure our network is properly balanced, I'm going to put batch normalization. So, and what is the input to this layer? It will be the previous layer. So it's convolution 1. There we go. And now, what's the next step? Important step? Max pooling. So we'll be doing max pooling over here. Pooling 2D. And our pool size will be 2. So it will divide the image by 2 technically. 2, and then we'll go back to BN. So the previous layer will become the input to the next layer. Simple. Let's make one more block. We'll repeat the same steps. So convolution 2 is equal to convolution. Let's put, usually in a progression you would do 2 raised to n. So we did 8. Next will be 16. So that's the usual progression, I would say. So we'll do 3. We'll do activation equal to ReLU. Same stuff. MX1. So so the next block, the previous input was MX1, so that will be the input to the next block. Similar thing. I'll just create one more batch normalization layer. Cool.
Can you not recursively call this?
You can do that actually. No joke. You can actually create a wrapper function to do all this, but just for illustration purposes, I'm doing it step by step.
Mm-hmm.
Most people for research, right, they create wrapper functions for creating the data sets. For example, so you'll have a function that will call multiple values of convolution 2D, And yeah, as you said, like you can do it recursively, definitely. But just for the sake of keeping it simple, I'm doing it step by step. Most
Yeah.
people will most people for projects will do it. So you'll have different arguments. So for example, you will have one argument for number of convolutional layers, then you'll have the stride length, then you'll have the padding length. So that's how usually people do. Like even for my projects, I've done like that. Or else it becomes very tedious typing the same commands. But for now, I'm just keeping it simple by just typing it all out. So
Yeah.
definitely,
Yeah.
if you do a project on deep learning, make sure to learn how to organize your matter basically. So you'll have a data set, and within the data set you'll divide the data set between training, testing, and validation, and outside of that you'll also keep wrapper functions ready to be used.
Yeah, just like in normal
Def-
programming where you have like your unit tests,
Definitely,
you would have like a
definitely.
separate file, I guess, for testing.
You will,
Yeah, for my
there's even testing for this. There's even testing in deep learning. Remember, like you'd actually
yeah.
pass. So that's called hyperparameter optimization in the case of deep learning.
Mm-hmm.
And now
For
here's the
yeah.
finally classification. We can finally do that. So we'll have of course. So since okay. So your input layer is like 28, 28, 3. So your input is that much. So in the first layer, it will become 20, 28, 8. So the filters have increased from 1 to 8. So think of this as a filter. So in this case, in grayscale image, it's only 1, but then it increases to 8. Then we downsample it in the max pooling layer. So in the down in the max pooling layer, it'll become 28, 28. Oh, I'm sorry, 14, 14, and 8. Okay, so the next input will be 14, 14, 16. And then over here, it will be, I think it will be around, what do you call this? Yeah, sorry, 7, 7, and 8. This is not guaranteed, okay? This is only in the case when you have a padding layer which is just the same, which is not usually the case, but I'm just showing you how it goes through. So first, your filter size will increase, then your max pooling layer or whatever pooling layer you use will downsample it to a smaller size. So you're increasing the number of filters technically. One moment. Okay, let's go back to what we're doing. So we'll flatten it now. So since it's like 14x 14x 7, and I want to get to a classification stage, I'll first flatten it. So this will make it all into one line, so a fully connected layer. So you'll see it when I put the summary. So flatten, our input is the previous max pooling layer, and now we shall put a few dense layers, fully connected layers, like how we did last time. So we'll have dense. Let's just put maybe 100. Activation is ReLU again. ReLU with our, okay, that's all I guess. Our previous layer was flat, and our final actual classifier is this. So you have 10. So you have 10 classes. So 10, and our activation will be softmax because we have multiple classes and not just 2. In the case of over here, you would put sigmoid if you only had binary classification. Remember that. And now we should declare the model. So we'll just declare the model. So using the model API, you will do it like this. You'll call the model function. Your inputs will be equal to input layer. So you can have multiple inputs and multiple outputs as well, but that's a bit of a complicated task, and I'll maybe take it up in a future session if needed. So that's there. So we have this. You should not throw an error, of course. Okay, it's cool now. So now after we declare the model, we have to compile the model. So we'll do cnn model dot compile, and this is where we specify our loss and optimizer. So in this case, our optimizer will be Adam. So it's not necessary that you take Adam. There's a huge research regarding what optimizes better, but I think Adam is kind of standard because Adam is ADA grade. There's ADA delta. There is stochastic gradient descent, which is quite popular. So in this case, I'm just taking Adam, and we'll just take our loss as sparse categorical cross entropy because we have multiple categories over here and not just 2. In the case of binary, you would actually just pick binary cross entropy. Entropy, okay, and then I guess that's. And finally, we have to specify our metric. In this case, we'll just simply pick accuracy. So that's it. So it shouldn't throw an error. Cool. So now we can see how our model is right now. So model.summary, if you call this function, so our input is 2021. The first layer is adding on the 8 filters. It goes through batch normalization, it goes through max pooling, and it goes same thing goes around and around. Okay, the filter size isn't exactly isn't exactly divided by 2 because I didn't put padding. I didn't. So you have a padding function within convolutional layer. So the padding, if you put it as same, it'll definitely just be the same division. So it'll always divide by 2. But in the case I haven't specified it, so it's valid. So it's going to do its thing. So it's not a big deal over here. But in some applications like autoencoders, you do want the layers to be consistently divided by 2. In that case, you will definitely put padding is equal to same. Depends on the case again. So in deep learning, just like machine learning, everything has a case and purpose. So we go to 400, we go to 110. So we have 42,000 parameters to train. So now there's one more thing we should do actually right now. We should have a validation data set. So a validation data set will basically compute the error after one run of an epoch. So an epoch is basically one full run through of all the 60K samples. But I do want to reserve some amount of data for validation purposes. So I'm going to do that. So let's go to sklearn. Sklearn has many good functions that you can use with the NumPy. So I'm going to get the train test split. This is the function that will help me split the dataset. So my new x train, my x valid, my y train, and y valid is equal to train test split. And I'm going to pass in x train and y train. And then I'm going to give it a test size. So in this case, it's actually validation size, but in this case, it's validation. So I'm just going to give like 10% of the 60,000 of that 60,000 will be reserved only for this, only for validation. And this is just the seed value, and I'm going to keep it as it can be anything. I'll just put it as 51. Doesn't matter. So we have a new data set. So now let's just print it out. Just give it some time because it's splitting the data set right now. Okay, cool. So some amount of the data set has gone into the validation data set. So 10% of 60,000 is 6,000. So 6,000 has gone into my validation data set, and only one, and the remaining is still in the training data set. So now we'll actually do some training. So we'll do model.fit, and we'll give it as x train and y train and epochs equal to 10, and validation data is our new set of data. So it will be x valid and y valid. I guess that's all. So now our model will start training. Cool. So Salman, are there any questions in the chat while this thing trains?
Let me have a look and see. I haven't seen any. There was one, but I answered it already, and it was from Ganesh, who was asking if CNNs can only be used for images. I answered saying that
No,
it can
no,
be
no, no.
applied to other domains.
It can be applied to, this is a very important thing that you'll see soon. So the things that CNNs can be used on any kind of data that requires spatial information. For example, I can give you a speech. Speech is spatial because the word before it and the word after it matters, right? So it's spatial information. So you can apply. So CNNs are applied especially for speech recognition, image captioning, and images by themselves. So any data that has some sort of spatial importance can be used.
Yeah, even like neurolinguistic programming. Like
Exactly. So CNNs can be used in that case as well. It's not usually people use long short-term memory LSTM networks, recurrent neural networks, but it's not compensated to use RNNs. You can also use CNNs. It again, as I keep repeating all the time, every network has a cause and purpose and can be repurposed for something else. That's what I actually like about deep learning. It's quite flexible. Okay, this is gonna take some time. It's okay though, not a big deal. So what I can
I
do?
think that's it.
What?
There was someone who said, can there be zooming in? But I've tried to zoom in a bit.
Oh
But
my God,
I've been zooming in and out. But I think it's fine.
is it okay? Okay, I'll just kind of make it a shorter thing. So I'll just interrupt the kernel, just give it 2 epochs, and just make it train for 2 epochs. Because 10 epochs seems a bit too long because the session will run out, so that's why. But you can train how again. So picking the number of epochs is again another hyperparameter. Hyperparameter basically means it's a variable that's very arbitrary. So if you think about epochs, there is no right rule to pick how many epochs. It can be 100, it can be 200, it can be 1,000, it can be 10,000. So that's a hyperparameter. So another hyperparameter would be your filter size. There's no single science to picking a filter size. It's all trial and error. So the art of finding the right hyperparameter value is called hyperparameter optimization or hyperparameter tuning. So Keras has a very good hyperparameter tuning system called Keras Tuner. So you can look up on that. So you can see within the first epoch itself, it's actually reaching already 88% accuracy. So it's actually very good. But remember, it's not the only indicator that your model is performing well. Remember, your loss should also be low. Okay, let's see. One more epoch to go, then we can quickly find our output.
I was doing what was it? I was trying to do local. You know how you can do local thresholding instead of like global thresholding, and that.
Yeah,
I was trying
same
to do
thing can be
that.
applied in like CNNs. I forgot the terminology, but it's something similar, like localized convolution, global convolution, something like that.
Yeah, no, I think that there's a term. I can't remember either because there's multiple ways of saying it. I could try to look it up.
Go ahead. I
But
forgot.
that involved me. I was trying to, well, as opposed to using the same file, I guess that was where it's a good use case to use a different file. So then you can call that function within it, and it's like sort of object oriented in a way, but it's just neater. Segmentation using adaptive. Is that it? Adaptive.
I think yeah, I
Yeah,
think
local
something related to
adaptive.
adaptive.
Yeah.
I hear it's on tip of my tongue, but I totally forgot about it.
There's like it's like there's Otsu's method, but this is like getting into different
Oh yeah,
ways of.
Otto's thresholding. It's one of the classic ways of extracting features, I think so. So yeah, back then you had to do all that stuff, but CNNs can actually do segmentation quite easily without thresholding.
Yeah. I was going into I was trying to do some. I ended up instead of just using the RGB, I ended up just using I converted it to
Grayscale?
grayscale.
Oh no.
It was so pointless.
I mean, in some cases it doesn't matter if it's in grayscale, but if it's stuff like cancer images, like what I'm working on, right? You do need the RGB for sure.
Yeah, because like I was like, what am I supposed to do? Like I've already made it grayscale. I'm just trying to show parts of it, and then I realized, oh wait, it was the original color anyway. It showed one channel,
Oh
and then
my goodness.
that was it.
Genius. That's good. So since we have a model trained, we can evaluate on the test set. So if we evaluate, so it'll just give us a test loss and test accuracy. The verbose parameters basically says it'll give you everything basically. So in our case, our loss is 0.2984 and our accuracy is 89.8941. If you run it for 10 epochs, as you'll see in my original file, it's around 90-ish, so above 90. So it's actually very good actually. So now we need to get our predictions. So our predictions is equal to CNN model predict. So you'll only pass the test variable. So since it's a multi-classification task, so the prediction will give you a list of probabilities. So I'll show it to you guys. So if I just give prediction of 0, you have all these probabilities. So if you want to get the actual output, in this case it's actually 9, you have to use argmax. So it's a function in NumPy which will give you this thing. So if I give it as predictions 0,
We've got a question in chat. I
yeah,
was So Nishan's question is regarding GANs. From my understanding of GANs is that GANs is like you give it data and then you can generate similar
GANs,
data, right?
yeah.
But then
So
CNNs just
there are
recognize.
two parts of GAN. So within a generative adversarial network, you'll have two networks. One network is called the it's called a producer, and this is actually a different term for that actually. And the second
The
one is called
generator?
no, generator and
Discriminator.
discriminator.
Yeah.
Exactly. So the idea is that the generator will produce an image, and the discriminator's job is to see if it's fake or not fake. So at the end of training, the generator is supposed to produce a very close representation of what you want to do. For example, if I use a GAN on MNIST, my generator should be able to give me picture perfect ones and zeros basically. So it's supposed to give me like perfect digits basically. So when I call that function, it's supposed to give me 0 1 2 3 4, like it should be indistinguishable from the original data set. So one good application of GAN I want to talk about is that if you train a GAN to properly, you can generate more data. So in the case of machine learning, one issue is of course you don't have enough diverse data. So you can train a GAN, and then from there you can actually create fake examples so that the model can train on those fake examples.
Yeah, I think one example of using a GAN, I guess, could be I think my friend did a project of this in high school where
Style
he
GAN.
sorry?
So one popular GAN people keep talking about is cartooning images. For example, you give it some
Yeah.
kind of painting, and it actually
Yes.
changes the style to
That's
something
adaptive
else.
learning, right?
Yeah, so one popular one was Mona Lisa kind of images, and the other one was Van Gogh style images. So if you train the GAN on whatever images that you do, so at the end of training, if you give any sort of image, it'll Van Gogh it basically. So it'll
Yeah.
be similar to say Van Gogh, so like that. So it's a very popular field like, recently because the network was introduced by Ian Goodfellow quite recently. I think 2014.
Yeah, no, I was looking at a GitHub
Oh yeah, look
repository
up on
recently.
Ian Goodfellow. He's amazing, honestly.
I can't
He's
remember what it's called. It's not adaptive learning, is it? It's something
No,
else.
I don't know if
There's the Van Gogh. I can't
no,
remember.
I think it's I might be wrong there, but I think it's just I also don't know the term honestly.
Yeah, it was really
Look it up,
cool because
Salman.
you just give an image and it creates a Van Gogh image. It creates like a Da Vinci image. It's pretty cool. There was a
Basically,
GitHub on it.
it's a generator model. Basically, it creates stuff basically.
Yeah, I think my friend did a project as well where
You
he
sample it.
basically gave a bunch of stories and then like it would output human-like text.
Yeah,
Similar, which is GAN, I
it's
guess.
used for speech generation as well as voice generation as well.
Yeah.
One of the application of GAN in terms of music is that you give it a particular chord or whatever sequence of the notes, and it transforms that notes into like a proper like melody or kind of
Yeah, that's what he did
a
as
chord
well, I think.
progression.
I think that
So
was
that's
his end goal,
it's
yeah.
actually kind of fun.
It's pretty
Imagine
cool.
robots taking over music.
Yeah.
They've actually done it actually before.
Yeah, no, yeah.
Uh,
That was his
Eurovision,
final
I think
project,
so.
I think. Pardon?
Yeah, there was one video on YouTube which actually does this. It's an AI generated song. It's actually pretty good.
Yeah, so that was so I think my friend's first part of the project was to do a story. I think he used a pre-built algorithm to do the whole story thing. And then his
Mm-hmm.
final one was to basically create music. I'm not sure if he
Well,
got
that's
there in
actually
the end, but it was like you would give it like, for example, Mozart, and then it would create its own version of Mozart, which is pretty
exactly.
cool.
So it's actually transferring the style of that. So you get the same music progression, like in terms of even musical notation. And it transforms it into a certain different type. Basically, that's called
Yeah.
genre conversion. I think so.
Genre?
Genre, like the type of music.
Oh, right. I thought you're
Oh,
giving me
sorry.
like a term like genre classification or something.
That's okay. So as you can see over here, the original testing image is of class 9. And of course, what is our class 9 again? Ankle boot. Sorry, ankle boot. So our ankle boot is so our model is actually predicting ankle boot properly. So you can see it's actually learned the features well. So let's just illustrate this again. So let's make one more PLT figure. I'll just make it fig size. Make it a bit big because I want to give you like 100 examples. So I want to give you a big thing. So big 50/50. Okay, that's good actually. So again, another loop for this. in I range 100 because we'll have 10 rows and 10 columns. So I'm keeping it as 100. So let's do a PLT subplot. And then we have 10, 10, and then we have I plus 1. I plus 1. Oh no. Again, plt.xticks, same thing. So your plt.xticks is nothing again. plt.yticks is nothing again. Oh no. Oh no. Okay, this is where. And of course, our grid has to be false. We don't want any sort of grid over here. And we'll do plt I am show. So since we've expanded our image to include that extra channel, we don't want it anymore. So we'll just do np.squeeze. We'll remove that extra channel. And we put it as x test of I. And the C map will be gray because all our images are grayscale. And then we'll give it a title, of course. Title will be predicted. We'll be formatting this /n, and we'll have actual. So our actual, our predicted will be np.argmax of predictions of I, and our, one moment, where am I? And our y test will be our actual label. Now here we go. So one more thing we have to do is finally, we'll just again put our clothing label as well, because just to be more illustrative and don't confuse anybody else. Class clothing of test of I. And finally, we'll do PLT show to show us the image. Give it a second because it'll take some time to plot the entire 100 images. I'll have to zoom here because it comes out kind of small. Come on. It's taking a bit of time, isn't it? That's okay. In the meantime, I'll just quickly write the other part of the code. Oh, it's right here. So we can see all our predicted labels. So in some of the cases, it's actually wrong. For example, in the shirt example, it's actually saying it's 4, but it's actually 6. So there are some errors. In this case, the dress, it's actually predicting 0, but it's actually 3. It's wrong. In some cases, it's actually predicting for sneakers 7, 7 is actually working right. So you can see that our model is actually predicting almost 90% of the cases right. 9 out of 10 cases, it's actually working perfectly. So one other good package to use is sklearn metrics, which actually gives you a good gives you, like, has multiple metric functions. So in this case, we're going to use confusion matrix. And since our predictions are in terms of probabilities, we want to get the actual value. We're going to simply use np.argmax again and convert the entire dataset. Predictions, axis equal to -1. And we'll quickly run the function. Confusion matrix. And we put it as y test and predictions norm. And so the diagonal is showing you all the correct cases. The remainder are some errors. So in this case, it's predicting class 0, but it's actually supposed to be class 1. So this is the error. So these are the 2 errors, 15 errors, 19 errors. So all these are errors, but majority of the cases we're actually predicting it properly, as you can see by the 90% accuracy. So it's actually worked. So this is how we create a CNN network. I have 2 more things to discuss with you guys. One moment. We're back to the PPT right now. So where do you go from here? So there are multiple networks that you can play around with, and they all have their special quirks. For example, autoencoders are used for sparse representation of features. Generative adversarial networks, as Salman has mentioned, is for generation and style like domain movement, I would say. So you transfer one input to another input. That's called domain migration, I think so. Or I'm kind of making it up. I don't remember the terminology. I'm so sorry. The other one is computer vision related topics such as object detection classification. This is a very popular task used, and these tasks use CNN most of the time. So you can actually do object detection classification. There are multiple very good structures for this, like unit and segnet, and we also have recurrent neural networks using LSTM for speech recognition. So in a nutshell, deep learning has so many important applications that you can. So for any kind of task, you can apply deep learning to it probably. So what's next for me? So I plan to hold a session for helping you guys how to create and deploy these similar models using Azure. It's quite an important thing nowadays in cloud computing is to learn how to create those AI models and learn how to deploy them to different services. And we can also explore different architectures like LSTM, GANs, and autoencoders. If you don't want it to be if you don't want it to be a long live session, I can pre-record and upload on MSP Inspire, not a big deal. And if you want to truly get into deep learning and go hardcore, you can not use an API like REST like what I did and just use TensorFlow directly. This has a few benefits. It might be hard to use the backend only like TensorFlow, but it teaches you how. But it has more flexibility. You can define multiple inputs, multiple outputs. You can give each branch its own different loss calculation or something like that. So it's quite. So if you want to go in depth with deep learning, it's actually a good thing if you to go in depth with the backend. So thanks a lot, guys. I hope I didn't take too much of your time.
That was
Uh, and
brilliant.
like, sorry for like stumbling here and there. If I wasn't clear over here, Salman will be sharing the Python notebook with all of you guys, so you can actually go through it at your own pace.
Yeah, I mean that was brilliant as always. Vijaya's sessions are always really good, and like there's loads to learn. Um, Definitely, if Vijaya wants to come back, as she mentioned, she can do that whole demonstration and everything, teaching everyone again. We're more than happy to have her on again. I actually did manage to find the whole
The term.
the I was thinking of the name of the program or the library, which is called Adaptive Style Transfer. I'll share my screen
Oh,
on Teams
yeah,
as
yeah.
well. Have you seen
It's
it?
called, yeah, yeah. I've seen it, and the network architecture is called StyleGAN. I think so. If I'm not wrong.
Potentially. This is the thing. So like, yeah, you just give it an image and then like the Van
Yeah,
Gogh.
this
Oh, it's
this this
so
is the
good.
GAN. This is the GAN. This is the GAN.
Yeah,
Exactly.
it's so good. And it was like, I was trying to find the GitHub for so long. I remembered I sent it on WhatsApp. I eventually found it here. Um, yeah, my friend was telling me about this, and it's so cool. Um, it's just amazing.
Yes,
Uh,
because yeah, I think 2018 is when the GAN becomes very very popular. This is a very good resource, by the way. You can actually share it also with everybody else.
Yeah, I'll send it again. I also like regarding this being on you can do stuff on TensorFlow. Now you got mo.net, which has since version 1.3.1, I believe, so fairly recently. You can now use TensorFlow within. I think it's TensorFlow modules or something. You can use it within mo.net, which is pretty cool. So now we're on version
Okay,
1.5.0
can you show that?
preview. Pardon?
Can you like show the MO like thingy like
mo.net.
like the documentation? Yeah, just want to see it
Sure.
once.
Yeah. Let me get the which.
Oh yeah, yeah, that's actually good. We can actually have a session on ML.NET then.
Oh yeah, I did mo.net like as soon as it came out. Because it came out at build, and then I started like using it, and then I was trying to use it like in like the industry as well. And it's pretty insane how much you can do. Because like when people are like, oh yeah, we do machine learning, it sounds so complex. But then like mo.net is literally they've made it as the bridge between software development and machine learning. Um, so
So
it's
can
just
you
like a
incorporate
simple.
this in web as well?
Yeah, because it's literally you can just do API calls. Um, oh wait, am I getting?
This is
I
built
might
on
be getting a bit
.NET
confused
Core,
now.
right?
Uh, so it's open source, which you can
Yeah.
see. I'm not totally sure if it's technically considered open on. Sorry, if it comes under .NET Core. Oh wait, I don't think it's. Wait, I'm getting a bit confused between like Azure and ML.NET because we were talking about the differences today. But
Yeah, Azure
so it's
emphasis
not.
is there, right? So
Yeah.
it's pretty confusing.
So
It's
I
fine
don't
though.
think it's an API call. You basically can have this offline and you can train your models, and then you can then deploy this to Azure. For example, you could create a model in ML.NET and then put that in Azure Functions. And like you can do this in C#, you got F#. I believe you can do this in Python too. I'm not too sure. Maybe not.
I think there is no. I think it's only C# and F# only.
Yeah. So it's like
Not a big deal.
the basically, if you think about it as like a way of doing machine learning in C#, because like one of the projects I have on my GitHub was like literally you can do this in a few minutes. You just do so this is a price prediction. You basically give it a CSV and you just create like it would give you the best model. Basically, you can test it against so many models, like
Okay,
maybe like
so it's
30.
doing hyperparameter tuning. That's actually good.
Yeah, it's like it's like so quick, easy to do. There's like a wizard as well which can help you potentially if you get a bit stuck or if you're trying to get into this sort of stuff. I did a few of these like ML.NETs. So I mean, you don't have to go into TensorFlow if you want to stay on the Microsoft ecosystem. Like I did stuff on sales prediction, price prediction, like sentiment analysis, like a bunch of stuff when it first came out, and it's got way better now. Like now you can do the whole TensorFlow thing, all of that cool stuff. So yeah, I mean, like don't feel limited to that. Microsoft doesn't have it. I saw someone saying that Microsoft should make its own like machine learning language. They do have like all this stuff like Azure notebooks. They're supportive of this, and like it's like an open ecosystem now that is like open source and everything. They're making changes like can go to their GitHub. Like last change was yesterday, stuff like that. But yeah, that's the. I think we should get onto the Kahoot. I think I'm
Yeah, it's
rambling
actually
too
good.
much.
Thanks, man.
No, that was it's really good, really good. Okay, so let's get the Kahoot up. I've got it here. So if you want to play Kahoot, go and introduce people to the live stream, and we will play the Kahoot. Gonna hopefully, I think the live stream's on low latency, so I didn't make the questions too long. In terms of you have the duration of time to answer. So Vijaya came up with these questions. I've just put them into Kahoot. Hopefully the latency is not going to be too high. Is this?
And if you have any doubts with the questions, I'll be happy to answer them. I'm in the background anyway.
Yes, let me see. Were there any more questions? Bruna says, I am studying AI concepts and I am loving this video. Have awesome stuff from Ganesh. Congrats from Bruna. You're a great speaker, says Nishant. It would be cool to have a session on ML.NET soon. Definitely, Dan. I think we can try work on that. That would be good. I need to dive back and do that whole stuff. OMG is the Salman Chisti. PS, I am a fan. Who, what? Yes.
We should actually open a Salman Kisti fan club, honestly.
No, what? I'm so confused.
Why not?
Who is this? Oliver Queen. Thank you. Everyone join the Kahoot.it and the pin. Share it with everyone else. See if you like. If they won in the stream, just share it anyway. You can beat them in the quiz. This is a hard quiz. It's in-depth. Very good questions. Did you just come up with these questions off the top of your head? Do you just know all this stuff?
I think most of them are like pretty concept based, right? So I just thought of them off my head.
Yeah, I saw you were just like typing them in like question. I was like, what?
Question. Oh my God.
Alright, let's see. Where's the podcast stream? I think I answered that. It will be here on here. Let us know what you want to hear from Pablo as well. Like, it's whatever you guys want as well. You guys and girls and non-binary. I have to say that. I always have to say that, just to be safe. Get the questions ready. Wait, what? What do you mean? Get the
It's going to
questions
be like an
ready.
interview, right? So, I mean, like some
Oh.
questions you do need to think for a long time.
Wait. I thought you were talking about the Kahoot.
Oh, no, not the Kahoot. I mean
No.
Pablo's podcast.
Yeah. Oh, it is. David, do you want to join the call? Why are you talking in the chat? This is the time, David, to talk. What's this with the rocket?
Okay.
What are you doing with the rockets, man? What is it? Let me show
Yeah,
everyone
I mean,
what you're
way
doing.
to go, everyone, way to go.
What is
It's
this?
really fun. I mean, having everyone with the rocket sign. Yeah, they actually super fun. I mean, being in the chat and always around, to learn something from what we have been doing. So, thanks so much to everyone out there watching right now. We just want to keep encouraging you that keep inviting people from your community to keep joining us. We want to make sure knowledge isn't something people really struggle to get it anymore. It should be so much available, and that is what we are up to. So yeah, what do we have? Kahoots. Let's see the screen on Kahoots. Okay. I see you project the screen. We are not seeing it here, but I see it on the YouTube channel.
Wait. I'm
so
sharing
please
on
make sure you
Teams.
join the Kahoot. Okay, I'm not seeing it on Teams. Maybe okay, it will be in soon. I guess so.
I'll do it again.
Yeah, so make sure you join kahoot.it. Okay, and then also let us know what you want to hear from Pablo. Okay, so that we will keep him, so that he doesn't, skip that. Kahoot.it. Join HTTPS. Let me just make the link. HTTPS kahoot.it.
It didn't work for me. Wait. Never mind. Everyone, you
and
need to join
remember
this link.
Salman, was your caps lock broken or something? HTTPS.
I think so.
Kahoot.it.
I know. I was listening to your keyboard.
Yeah.
And are you on a laptop or something, Vijaya? Because I didn't hear your
Yeah, I'm
mechanical.
on my laptop. I didn't because my laptop only has like 2 ports, so the mechanical keyboard couldn't go there. So it's like just this keyboard.
Yeah,
That's
where's
what
your
the
Optimu blue switches?
the typing was like kind of slow because of that only. Because this is like mushy keys.
I was hearing your mushy keys. I was like, where's your blue Optimu key switches? And then
For Salman only.
Okay.
Thank you.
Okay, yeah. So make sure you call others to come and play along with us in the Kahoots. Let us know what are some fun things that you want us to do that we are not doing. I mean, we like to joke, we like to crack jokes. I mean, we like to have fun. So
yeah, but
make sure
only
you
good
let us
jokes.
know
Only good jokes.
what we've not been.
I mean, like
Remember, guys,
definitely. We do everything with plain
Safe
intention.
jokes.
So
Pardon, Vijay?
No, we can host whatever session you want, provided you actually tell us. So please go ahead. There's no shame about it. It's just tell us what you want to do. AR, ML, what it is.
Yeah, Kahoot.
Exactly.
Is that loud enough? Nishad say you're really.
And someone called Salman.
I think at the
Is that
at the start
machine
at the start of-
learning,
at the start
ML?
of,
It's AML, machine learning.
At the start of the session, I mean, I was the only fan. Okay, I and Salman, let me just say, because we were the ones
What?
speaking, fan of Vijaya. But I'm sure now people are now fan of Vijaya as well, right?
I'm so confused.
I mean, yeah, people are now enjoying Vijaya's talk. I mean, I was the one that really felt like always hearing from Vijaya, because when Vijaya presents, I mean, it's like I don't know, like a super-woman presents.
What?
Thanks, bro. Thanks,
What?
bro.
What do you
I'm
mean?
very happy to call that.
I think Vijaya likes to be a tomboy. That's Vijaya's
Yeah, I'm a tomboy, but I'm
nickname.
come on.
Calling her superwoman.
Oh yeah. So
We have
definitely-
Salman MI.
Yeah.
Let me finish.
Nishan says
I think it's
good speaker.
Machine learning.
Okay, so let's just put the Kahoot out and then let's play it so that we keep the recording very short, so people who would want to watch it later can find it interesting.
Yeah.
All
Okay.
right, so let's
We'll
put
give
out the
it
Kahoot. Sure.
1 minute. 1 minute. 1 minute. Any questions for Vijaya? I'm trying to switch to the stream, but I've got so many programs. Yeah, agreed, Nishant. People from Arrowverse know Salmon. What? People from Arrowverse know Salmon. What's Arrowverse?
That DC character Arrow kind of thing.
I don't know what
I
that
don't
is.
watch.
I have no idea.
Okay, so CNN versus GAN difference. Okay, so CNN is basically GAN is basically an extension of a CNN. So a GAN is the difference between CNN and GAN is basically like how they function. So usually a plain CNN's job is to just classify stuff, but in a GAN, this convolutional layers are arranged in CNNs in such a way that they perform different functions. So in the case of GAN, you'll have one CNN focused on creating the dummy. And in the second part, the CNN is focused on discriminating whether it's a dummy or not. So that's the main difference, I would say. But so the thing is that you can make a GAN with the CNN type, or you can make a GAN with a RNN type. So it again depends. So what the main difference is that an autoencoder's function is basically to create a sparse representation. A GAN's job is to create and discriminate, and a CNN's job, specifically vanilla CNN, is to just classify objects usually.
Yeah, I'm a fan of GAN. It's pretty cool. It's like saying how like you can just create stuff which has like never been made before. Because that's the thing. Like people, like, imagine using a GAN for ideas. You just give it a bunch of ideas, idea generator. That's I should patent that. Okay, we're gonna get started. We are ready, I assume. So how it works, just to explain to anyone who's new, basically the questions will show up on the stream, okay? And shortly after the questions appear, you will basically see the answers on screen, so on the stream. But you, on whatever device you've gone to this website on, you will not see the answers, but you'll see corresponding options which will basically reflect what the answers are that you see on screen. It will make sense. If you don't know what it is, the first question can be like your taster question. It's about the learning. Okay, there's not many questions in this, but they're good. It's a good way to consolidate your knowledge. Okay, so are we ready? We're gonna start. Okay, Vijaya, would you like to read the questions out and explain the answers, or?
Sure. In the meantime, I'll also be answering Shahir's question in the chat. One moment, I'm like typing out the answer. So go ahead.
Okay.
Let's just start Lamont.
Okay, I'll read the question out and then you can do the answers explaining. Cool. Okay, 3, 2, 1, go. So the first question is, which is a deep learning model? So in the top left, it says k-nearest neighbors, then it says linear regression, autoencoders, or naive Bayes, or Bayes.
Naive Bayes, bro. Dude, it's Bayes, bro.
I've never said that. I don't think I've ever said that before. I think I've never seen that before. Oh, that's my bad. I'm not that good at deep learning stuff. I'm more into the, I guess, ML. That's no
So
excuse.
autoencoders are a type of deep learning networks. It can be just dense layers. It can be CNN. Doesn't matter, but it's type of deep learning network.
Cool.
Whoa.
Hope everyone
And
understands
3 people
that.
had it.
Yeah, and like
Yeah,
6 people
it's
didn't
cool.
answer.
It's actually cool.
Where did everyone else go?
Yeah. Oh.
Okay, next.
Sorry. Just feel free to make mistakes. I mean, mistakes makes you better. Just feel free.
This is the advice for like any tests. Never leave a question blank unless you get deducted points for it. Here you don't
Yeah.
lose any points for getting it wrong. So, next question. You literally could have 999 if you guessed it fast enough and you guessed it randomly. But that's not necessarily the point of this. What are the learnable features of a convolutional neural network? Filters, padding, strides, or activation? Remember, give us an answer. I hope I've got
Okay, I'm just thinking, what might the answer be?
Yeah, there's
What might
ultra.
the answer be? Maybe I like the color green.
Oh my god.
If you like the color green, you would be wrong.
Okay, so it's filters.
Don't be
The learnable
misleading.
filters of a deep learning network or of a CNN is definitely filters. Those filters are what actually learn what features you have in that picture, and then they activate the moment that feature is like around matched, I would say. I'm surprised only
Awesome.
one person. Come on, guys! I said like out loud filters, learnable filters.
So I told you this would be hard.
Okay.
Hey Ganesh, look at Ganesh. Oh, Leet. Oh my days, one of a Leet. Not even Leet, man. Not even.
Yeah.
I'm joking.
Yeah, the fun thing is that whether you are wrong or you are right, we are learning more, and then Vijaya is here to answer. So feel free. It's actually nothing. Okay. Let's see, but we surely want to see some people climbing the leaderboard. So let's see. Okay.
So that was the Leet. What is the novelty of convolutional neural network? It performs better than DNN. It's designed to work with imagery. It performs better than other ML algorithms. Well, it performs better than CNN. Sorry about the capital IT.
Oh, IT performs better than CNN. IT, bro.
Well, to be fair, that could be the answer. But no, it's not.
Okay. Be quick.
Oh, that's actually
Be
good.
quick. Make sure you
Was
click on
this
it
like
before.
from
I'm
Dawood?
glad.
Like Dawood did
Okay,
like 10
yeah.
years ago.
So yeah, CNNs basically work on
Oh, no.
imagery, but it can be extended to any sort of application that has spatial importance. For example, speech. It can be applied to like speech. It can be applied to captioning. It can be applied to even images. So anything which requires spatial in the dataset name, it can work.
Hope that all makes sense to everyone in the chat. And we've got a move in the leaderboard, with the leaderboard coming up to second. True or false? Convolutional
awesome.
neural networks can only work on images. Oh, this is answered so many times. Everyone has to get this right.
Okay, this.
Nishant, by the way, it's not guaranteed that DL
The good
networks
thing
will
is-
work better than ML algorithms. In some cases, for example, in clustering algorithms, so like sometimes ML does perform better than DL. Because the DL network is burdened with two tasks: feature extraction as well as the other task. But in the case of ML algorithms, you usually focus on the feature extraction first, and if your feature extraction is very good, your ML algorithm can actually perform better than the DL algorithm actually. So it's not guaranteed that DL is always better than ML.
Very good, very good.
That's a deep knowledge. Come on.
Alright, so it's the podium. Let's turn up the music.
Oh
For
no,
cheat.
the music.
Okay, but Nishant
Yeah,
says,
for-
isn't it
very
better
good.
than other
Needed.
machine learning algorithms? Is that what you just answered?
3 out of 4. Let's see, is it GAT 786?
Oh, okay. Chante, okay.
Leaderboard, wow.
Congrats! Woo! Let's have some
Oh.
enthusiasm.
Okay. Is it Ganesh or who?
So, if we want feedback from everyone, if you want. Can you give feedback? Ooh, can we see your feedback?
Yeah,
Everyone, put feedback. I want to see the feedback. I think
Yeah,
there's
yeah.
an update.
Someone, can you put a link there? Can you put a link to I don't know, maybe the talks they should submit?
Oh, okay.
If you want to see any talk, I mean, just submit it. Yeah, and also, we know we don't have I mean our swags now, but we keep saying that we will have swags to distribute. You remember that Mr. Power Apps? I mean, Brian said he'll be giving out some cool
plushies.
stuff.
I
Some
think
stuff
I
for
think
you
that's
guys.
for potentially in his next talk. I don't think that's for this talk. for
Yeah,
his
yeah,
last
yeah,
talk.
yeah, yeah, yeah.
In the
Yeah,
future, we could.
that's not for this talk. I'm actually, yeah, I'm only saying that in the future we don't have the swags now, but definitely we'll be getting some swags to MSP Inspire. So make sure you always tune in to MSP Inspire and then click on the subscribe button right there, okay? And click on the bell icon as well so that anything we post, you get an update on it. Make sure you hit on the like button, and there is also some links down there. I mean, down the video, just down the video, and
I've
come
just
back
put
to
the
this.
link if you want to tell us what talks you want to hear next. That's
Awesome.
including from MS employees. So next week will be Pablo. The week after will be another MSP. And then the week after, MS employee, potentially, or MVP. So yeah, just let us know and we'll try to source out, those speakers for you. So like, yeah, a lot of, as I mentioned at the beginning, a lot of you mentioned you wanted machine learning in Python today or deep learning. Today we had Vijaya who delivered for that. That's one of the links as well. If you want to follow
Yeah,
Vijaya as well on social media, here's her social media as well as
yeah.
ours.
I don't know. Yeah, I am. Just let me cut in small. I think there are a lot of people who know Python, who might know Java and Co, but they don't know how to put them together to build a project. Is that what is missing? Let us know if that is what is missing. Just give us a feedback so that we see whether we have to maybe plan our sessions to build something along the way. I don't know. So just let us know. If needed, reach out to me on LinkedIn. All right, thank you so much. Reach out to all of us. Vijaya's link is over there, Twitter, everywhere.
Yeah.
Thanks, guys, for coming.
I'm not.
Yeah, and thank you so much,
Oh,
Vijaya. We're looking forward to having you again as well.
okay, Salman. Would you drop the video? I mean,
Oh, the
the
trailer.
tease,
Oh,
the
have you?
trailer. Yeah.
Did anyone notice the cool additions to the trailer today? Anyone notice what was added?
Oh,
Oh, the stuff regarding
I didn't even see it.
our previous session, right? Of women in
Yeah,
WWT, that one.
yeah, and added Miriam, Samit, and Brian. So we're trying to update it to keep, keep. Next week, Vijaya might be in the trailer.
Oh, yay!
And that,
Some stardom.
oh no, I think you were already in the trailer. I think it was probably your screen
No,
doing some
yeah,
Python. I think.
yeah. The
And
old
notebooks.
dense net, like the dense network I made, like back in the
Yeah,
Inspire session, right? That's there.
yeah, in the virtual call, it's like, yeah, but yeah, no,
Yeah, and then
this is
yeah. Yeah, and thanks so much for having all of you. But I think you need to play it. I've not seen it yet.
huh.
Let me go on YouTube. Make sure
Okay.
I'm not.
Yeah, you can reach
Yeah,
Vijaya here. Here's
Yeah,
Vijaya's.
reach me in DM, not a big deal. Reach me in DM on Twitter or even on LinkedIn also reach me. So the thing is that I'm not very experienced with computer vision, so I'll try finding the answer for you definitely. If you need to, if you have any more questions, I'm mostly specifically focused on cancer detection and classification technically using CNNs. So that's there. So if you want any help, just please ask me. No big deal. I'll find the answer for you.
I'm interested in the
yeah.
whole computer vision stuff or like image recognition. If you want to ask something, ask me as well. My DMs are open on Twitter. But that's it, I think.
Yeah, feel free to reach out. Feel free to reach out as well on anything. I mean, I'm just a universal guy, so anything, just ask me. All right. And then also shout out to Sandarishwa, shout out to Nishant, everyone in the chat. Shout out to you guys. Thanks so much for tuning in. Make sure you invite others to come here and then join us next week. Thank you.
Cool. Yeah. Yeah. Subscribe, and we'll see you next week with Pablo. And have a great evening. And stay safe. Wash your hands and
Yeah, wash
social
your hands
distance.
definitely.
Definitely.
Social distance.
It's
And don't forget to code, okay? Don't forget to code.
oh yeah, this is a great chance to code like
The best part about being a programmer is that you can code anywhere you want. So just sit in the
exactly.
house and do coding.
I,
That's what.
yeah. We should definitely we'll discuss this after the call, like
Sure,
all
sure,
this
sure.
stuff.
See you guys.
If you're all free. But yeah, see you. Bye everyone.
We see the sunrise. that